Hello, this is Miss Nicholson, and in this video, we're going to be looking at the polar coordinate system and how to plot points in this polar coordinate system and convert between rectangular and polar coordinates. So you can see here on example one, a polar grid. Looks a little bit different than our rectangular grid, but if you notice here, we kind of got the XY axis still in there. And so we're going to just plot these points. Polar coordinates come in the form r theta, where r is a radius and theta is an angle. So let's just start with this 0.4, 5 pi over 3. Now, when I graph in polar, I usually like to find the angle first. And so I'm going to go around here to 5 pi over 3, which is, of course, in the fourth quadrant. So we're looking at this spoke right here at 5 pi over 3. My radius is 4. And so you can see these circles moving out from the center. So I'm going to count a radius of 1, 2, 3, 4. And so that point is going to be right there, point A. Next up, point B, 3, 7 pi over 6. Again, I'm going to find that theta first, 7 pi over 6 over here in quadrant 3, and then a radius of 3, 1, 2, 3. Right there would be point B. Now for point C, notice that we're given a radius that is negative. And so we're going to see what difference that makes when you have a radius that's negative. Again, I'm going to find that theta first, 5 pi over 4, of course, here in quadrant 3, 5 pi over 4. If the radius is negative, instead of counting my radius of 2 into quadrant 3, I'm going to go into the opposite quadrant. Because this angle is in quadrant 3 and my radius is negative, it's actually going to end up plotted in quadrant 1. So here's a radius of negative 2 at the angle 5 pi over 4, and that is point C. Next up, you can see point D has got a negative angle, and we're just going to find that angle working in the negative direction. So I'm going to start here at 0, and I'm going to go negative pi over 3, which puts me on this 5 pi over 3 spoke, but it's negative pi over 3. And my radius is 2. So I'm going to count 1, 2. And right here would be point D. The final example here, I've got a negative angle and a negative radius. Again, I'm going to start with that angle, negative pi over 2. Of course, it's going to put me on this spoke right here. And then if my radius is negative, instead of graphing down here between quadrants 3 and 4, I'm going to go up between quadrants 1 and 2. 1, 2, 3, 4, 5. And so that would be the point negative 5, negative pi over 2. Now, as you look at these points, you might be thinking that we could use other coordinates to represent the same point. For example, the point that we just plotted, negative 5, negative pi over 2, this could be a theta of positive pi over 2 and a radius of positive 5. And that's something unique that happens in the polar coordinate system that does not happen in a rectangular coordinate system, is that we can write different coordinates representing the same point. So let's consider that here in example number 2. We're going to write 3 different sets of coordinates that will all work for the same point. So first of all, I'm going to go ahead and plot this point just so we can see it up here on our grid. 2 pi over 3, spoke here in quadrant 2, and a radius of 4. 1, 2, 3, 4. So here's the point. I'm just going to circle it because that's the one that we're working with here for example number 2. Example 2 point. There we go. We've got it labeled. So what if I wanted to write this with let's find coordinates with a negative radius, but a positive theta. Well, my radius is going to be 4 units, whether we're going positive or negative. So I'm going to make that radius -4. But that means in order to get this point, I don't want 2 pi over 3. I want that same angle in the opposite quadrant, which would be 5 pi over 3. So again, if I went to 5 pi over 3, which is this spoke, and then plotted a negative radius, that would take me from quadrant 4 to the opposite quadrant, quadrant 2, and I would end up at the same point. Now, what if we wanted to have a negative angle? Well, my radius is still going to be 4. My negative angle, before I even go up to the grid and think about it, I hope it makes sense to you that it has to be something pi over 3. It's going to have to be the same denominator. And let's see what it is. If I start here, -1 pi over 3, -2 pi over 3, -3 pi over 3, -4 pi over 3 gets me to that spoke. So -4 pi over 3. And the fourth one that I want to write, what if we do a negative radius and a negative angle? Well, my radius has to be 4. My angle has to be something pi over 3. But let's think about this. If I want this point here and my radius is negative, that means that my angle needs to be a quadrant 4 angle. Since my point is in quadrant 2 and I have a negative radius, I need to be using a quadrant 4 angle. I want a negative angle that gets me to that spoke. And so if I start here and go to this spoke, that's going to be negative just 1 pi over 3 is what puts me on that spoke. So all of those coordinates, even though they're different, they all represent the same point. So then let's talk a little bit about how we convert from rectangular to polar and polar to rectangular. Let's go back up here and talk about this point E. Remember, I pointed out here that we kind of have our XY axis. We could draw that in and kind of imagine a rectangular grid superimposed over this circular polar system. So this point E up here, it's on the y-axis. It's up 5 units. And so if we wanted to do E in rectangular, the x coordinate would be 0 and the y coordinate would be 5. It's on the positive y-axis. And so you see that we can have 2 totally different systems of coordinates representing the same point. Now this point's pretty easy because it's on one of the axes, but what about these points out here that are just floating in the different quadrants? How do we find rectangular coordinates that represent those same points? Well, we're going to go back to the basics on trigonometry, and let's think about how we graph angles. I'm going to call this angle theta. We're going to make a right triangle here, and I'm going to put a point out here that has the coordinates x, y. If I label this triangle, then this side down here, the horizontal side would have the length x. The vertical side would have the length y. And my radius is going to be the length of the hypotenuse of this right triangle. And so the relationship between rectangular and polar, regardless of the direction that we're going, is all based on this triangle. So first of all, since we have a right triangle, we know that x squared plus y squared is equal to r squared. And that means that r would be equal to the square root of x squared plus y squared. And it could be positive or negative. As we saw in the points that we graphed, we can have positive radii, we could have negative radii. So r is positive or negative square root of x squared plus y squared, just based on the Pythagorean theorem. Now to find theta, we're going to need to use a trig function, and we've got to be careful about which one we use. Remember, if I'm going from rectangular to polar, that means that I'm starting with xy and I'm moving to r theta. So I want to use the trig function that only uses x and y. I can't involve the r because R is part of the thing that we're looking. We're given X and Y, so we want to use those things. So our theta is going to be based on the inverse tangent of Y over X. Now remember, when we do inverse tangent, it's going to give me an angle between negative pi over 2 and pi over 2. That's the range of the outputs for inverse tangent. And so we may have to adjust that angle depending on which quadrant our point is that we're plotting. But at least it's going to give me that reference angle to help me figure out the angle that I need for the coordinates. So now what if we're going polar to rectangular? Polar means that we're starting with r theta. We want to end up with x and y. Well, let's go back over here to our triangle. If I know r and theta and I want x, I know r, I know theta, and I want x. Well, we're going to use a trig function because we're involving that angle. And that one would be cosine. Cosine would be x over r. And if I solve that for x, I'm going to multiply the r to the other side. X is equal to r times cosine theta. So that's how we're going to find an x coordinate, is to do the radius times the cosine of the angle. If I have r and theta and I want to know y, then of course we would use sine theta. And again, similarly, if I multiply the r to the other side, then y is equal to r times sine theta. So those are your conversion formulas. Let's use them to convert some coordinates. In example number 3, we've got a polar point, 2, 5 pi over 6. We want to convert this to rectangular coordinates. Now, when I do conversions, I like to just make at least a rough sketch of where that point would be. 5 pi over 6 is, of course, over here in quadrant 2, and a radius of 2 somewhere roughly right there in quadrant 2. Remember that x is equal to r times cosine theta. My r is 2 cosine of 5 pi over 6. And that would be 2 times, if I do this without a calculator, cosine of 5 pi over 6 is, of course, negative square root of 3 over 2, because we're over there in quadrant 2 where cosine is negative. And so x is equal to negative square root of 3. My conversion formula for y is equal to r sine theta. So y equals 2 times sine of 5 pi over 6. And sine of 5 pi over 6 is positive 1/2. So y is equal to 1. And so this point, if I'm plotting it in rectangular, it's going to have the coordinates negative square root of 3, 1. Okay, now let's go in the other direction. We've got an x and y, and we want to convert to polar, to r theta. Again, I'm going to plot the point just so I have a visual. 3, negative 3, somewhere down here in quadrant 4. So I'm trying to find that r and theta. Well, let's start with r first. R is equal to positive or negative square root of x squared plus y squared. So 3 squared plus negative 3 squared is equal to the square root of 9 plus 9, square root of 18, or 3 square root of 2. Now the theta. Theta is going to be the inverse tangent of y over x. So inverse tangent of negative 3 over 3, which is the inverse tangent of negative 1. Now, hopefully we remember that the angle whose tangent is 1 is the pi over 4 angle. And since this is negative 1, then the angle that is within the range for inverse tangent would be negative pi over 4. And so now I just want to take that reference angle and think about the quadrant that my point is in. If I go negative pi over 4, does that land me in quadrant 4? Well, yes, of course it does. And so we could use, and if I'm going to use this angle putting me in quadrant 4, then I want the positive version of my radius. So 3 square root of 2, negative pi over 4. However, we could have chosen to find a positive angle. Instead of using negative pi over 4, we could use this theta. The coterminal angle that's positive would be 7 pi over 4, because that's the pi over 4 angle that's in quadrant 4. Of course, we could have chosen to use the negative radius. And in that case, if I'm going to use the negative radius, that means I need the quadrant 2 angle, which would be 3 pi over 4. So any of those coordinates would be correct. And honestly, there's a lot of other coordinates that would also be correct for this point, because in polar, you can have many, many coordinates that represent the same point.